All right. Well, thank you very much for giving me the opportunity to talk about the epidemiology of pneumococcal disease in the UK. All right. So just for me to be able to gauge my talk accordingly, how many of you can name all the serotypes in Prevnar 13? Okay. So we start from the beginning. Which is a good place to start. So pneumococcal disease, as clinicians, we know it as pneumococcal disease. But in terms of surveillance, we have very strict criteria about what we measure and what we don't measure. And as you know, with Streptococcus pneumonia, you can have non-invasive mucosal infections such as otitis media and sinusitis, and non-bacteremic pneumonia would fall into that category. And you have more severe infection, which usually results from a bloodstream infection. So you get your septicemia, meningitis, and bacteremic focal infections, whether it's pneumonia, septic arthritis, or so on. And that's how we define invasive pneumococcal disease for surveillance. And it is really the invasive disease that we generally monitor. And from a surveillance point of view, what we normally do is that we have a conversion ratio of anywhere between 4 and 10. So for every one invasive case, we estimate there'll be between 4 and 10 non-invasive cases. So the epidemiology of pneumococcal disease is pretty straightforward. The highest burden of disease is in the first 2 years of life, and then it falls very rapidly. And for many of us, we don't realize that actually it starts increasing in adulthood, not in older adulthood. And, 45, 64, it starts accelerating up, and it goes up and up until 90. And even though generally we consider older adults at 65 plus, we are realizing that actually the burden at 65 isn't that big. It's 75, 85. So the older you get, the higher the incidence of pneumococcal disease. So there are almost 100 known pneumococcal serotypes, and they are numbered. The serogroups, like 7, tends to be similar, and within serogroups you have serotypes. You can have 7F, 7B, and so on. So it's important to know that there is some cross-reactivity between the numbers, but between different numbers there's no cross-reactivity. The serotypes are based on the sugar capsule of the pneumococcus, and each serotype is distinct from another, so you tend not to get a lot of cross-protection. There are 3 known vaccines available. That came in the UK. There's a 23-valent pneumococcal polysaccharide vaccine, and I won't say much about that. In 2000, a 7-valent vaccine was licensed. It's a conjugate vaccine. And the 7 serotypes that are included that are the 7 most common serotypes causing invasive disease in children. And this was replaced with a 13-valent serotype, which has 6 additional serotypes that came in 2010. There is another 10-valent vaccine called Synflorix, which is made by GSK, which the UK has never used. So I'm not going to tell you much about it. The history of pneumococcal vaccination really starts from the 1980s, where the polysaccharide vaccine was given to all those at risk from 2 years of age. When Prevnar PCV7 was licensed, we initially only used it in children and in those at risk. But we started an extensive polysaccharide vaccine program for the elderly from 2003 until 2005, so that all our elderly population was offered the vaccine over a period of 2 years. It was only in 2006, 6 years after other countries such as the United States, that we introduced the 7-valent pneumococcal conjugate vaccine into our program. Now, we did 2 things differently compared to other countries. We introduced it as a 2+1 schedule at 2, 4, and 12 months, and not the licensed 3+1 schedule. But at the same time, we had a catch-up program for all children up to 2 years of age. And the reason for the catch-up program is that the under-2s are the main carriers of pneumococci. And if you target them very quickly at the beginning of the program, you hope to get a much bigger herd impact because you eradicate the vaccine serotypes being carried, and therefore they can't transmit it to others. We have a really extensive surveillance program. This is just to show you all the interactions that we have. Essentially, every single pneumococcal isolate in the country is submitted to the National Reference Laboratory in our laboratories, and we serotype and confirm every one of them. If they don't send it to us, we get reports which we chase so that they send it to us. And we serotype around 95% of all the isolates. The main reasons for not serotyping them would be if the isolate died or they couldn't be resuscitated when it came to us. We have an extensive follow-up for the vaccine-eligible cohort, so we get detailed clinical history, vaccination, disease, and outcomes for all our cases. So I want to tell you what's happening now, but to get there, I need to tell you what happened before. We introduced the PCV7 into the childhood program in 2006, and we first published the impact of PCV7 in 2011. We have 4 years' worth of data. So what you will see is that the blue line is the, let's start with a simple one. The green line are the PCV7 serotypes in the under 2s. The vaccine came in 2006, and you can see a huge reduction in PCV7 serotypes in children. The non-PCV7 serotypes, the other serotypes, went up a little bit, but there is an overall decline in invasive pneumococcal disease for that age group. As you get older, we get the same effect, but less overall. And what we see is that in the elderly, we also see a huge reduction in PCV7 serotype IPD due to herd protection, but we see more of an increase in non-vaccine serotypes as well. So that there is an overall decline in invasive pneumococcal disease, but it's not as impressive as that. The big thing I want you to notice is that this is in the hundreds and this is in the thousands. So even though the major impact was in children, the number of IPD cases is much bigger in the elderly. The elderly is 65 plus. There are 3,500 adult cases in England and Wales compared to 200 in children under 2. So even though the incidence is highest in infants, the burden of disease is really in the adults and the elderly. What I wanted to point out with this slide is that within 4 years of the PCV7 program, there was a 98% reduction in IPD caused by the PCV7 serotypes. And the reason we have such a massive impact is because of that 2-year catch-up. We hit the whole group at the same time. We did see a little bit of an increase in the non-PCV7 serotypes, but more than a 50% reduction in cases. If you look at all age groups, again, what you see is an 84% reduction in vaccine serotypes in the age groups that weren't even vaccinated, and a small increase in non-PCV serotypes. But again, we reduced a third of cases across all age groups. That's a third of nearly 6,000 cases were prevented during the first few years of the program. Now, one of the things is that we do have a PPV program for the elderly. But when you look at the older age groups, the 65 plus, we see big reductions in the vaccine serotypes. We also see bigger increases in the non-vaccine serotypes, a 48% increase. But when you actually plot the cases, what happens is that you see the PCV7 serotypes going down really nicely. These are the non-PPV serotypes. Most of the increase that we saw were in the PPV additional serotypes. So what that tells us is that the reduction that we're seeing in the elderly is all due to the PCV7 in children and not because of the other serotypes that are in PPV. So by 2010, we already knew from our analysis that the maximum benefit of PCV7 would be 4 years. After 4 years, we will see no further reduction in the PCV7 serotypes, and we will start seeing an increase in the non-PCV7 serotypes. So the maximum benefit would have been 4 years. So the timing of Prevnar 13 was perfect because it came in exactly when we would want to replace it. And what was really good at that time was that the replacing serotype that we saw were nearly all in the PCV13 serotypes. And so when PCV13 came in, again, we saw the same things. If you follow this line, there's an extra line now. So the red line is the PCV7 serotypes that I showed you, and that went down and stayed down very nicely. The additional PCV13 serotypes went up a little bit and then came down after PCV13 was introduced. We saw a little bit of replacement disease, but a huge overall benefit from the program for children. And that trend continues in the other age groups as well. And in the 65 plus, what you see is this massive reduction in PCV7 serotypes. PCV13 serotypes took a bit longer to come down because we had no catch-up then. It took slowly for the herd protection to be offered by the PCV13 serotypes, because all we did is, after the 1st of April 2010, when you came in for your vaccine, you just got PCV13. So some kids got 7, 7, 13, some kids got 7, 13, 13, and the new kids got the 3, 13. So there was no catch-up at all. So the herd protection took a bit longer. But you can see now that the non-vaccine serotypes are going up. The replacement disease is going up a bit faster compared to the pre-vaccine period. But still, overall, there were big benefits in the program. And this was published in Lancet ID in 2015, if I'm not mistaken. But what we could see at that time was that we still had a 32% reduction in invasive disease after PCV13, which is due to a combination of an 86% reduction in PCV7 serotypes and a 69% reduction in the PCV13, the additional serotypes. And overall, we could still see a 56% reduction in overall invasive pneumococcal disease. There was some increase in non-vaccine serotypes, but it wasn't huge. So the overall benefits remained very positive. The only thing in 2013-14, the last year for which we had data, is that we saw this little bit of a blip that made us a little bit worried. And this is that blip over there. If you see the total IPD cases going up, just there. And it was one of the things that we were now 4 years into the PCV13 program, and we had a feeling that maybe the maximum benefit of PCV13 would have been achieved. So that means we wouldn't see much more reduction in the PCV13 serotypes, but the non-vaccine serotypes could start playing an important role. But at this time, I couldn't tell you which were the main replacing serotypes. After PCV7 came in, serotype 19A shot up, serotype 7F shot up, and we had a little bit of other serotypes that started going up as well. 4 years after PCV13, there were so many serotypes that went up little, but there wasn't any major replacing serotype that we could contribute this increase to. So what happened after that? And I'm going to present data until 2016-17, which is a year after that. So the first thing that's happened is that we've seen a massive increase in non-vaccine serotypes in the last 3 years. So everything was going well until we published the Lancet ID paper. And as a consequence of that paper, we now have a huge reduction in, huge increase in non-vaccine serotypes, very suddenly in 2013-14. So the first thing is the non-vaccine serotypes went up. The second thing is that the PCV13 additional serotypes stabilized. They stopped going down. You see PCV7 went all the way down. PCV13 serotypes didn't, and this was mainly due to serotype 3 and 19A. So there aren't many serotypes that you need to know about, but at the end I will remind you which pneumococcal serotypes you need to keep in mind. And what you see is that the overall incidence of invasive pneumococcal disease has gone up, such that we have virtually no additional benefit from the Prevnar 13 compared to the PCV7. If you look at the different age groups, what you will see is that PCV7 serotypes have remained very low. PCV13 serotypes haven't got all the way down, but they've stabilized. The non-vaccine serotypes have gone up a little bit, but we still have a huge benefit in children from the program. But the number of cases is 280. These are small numbers of cases, but the incidence is lower, and the kids have benefited greatly from the PCV13 program. There is no doubt at all that this vaccine has been highly successful in preventing invasive pneumococcal disease in children. But as you get in the older age group, 5 to 14, the cases are very, very low, 60 cases. But once you get into the adults, what you will see is that the non-vaccine serotypes really shot up, and the decline in PCV13 serotypes was less. And if you go in the older age groups, you can see bigger increases in the non-vaccine serotypes and a stabilizing of PCV13 serotypes, and perhaps an increase in serotype 3 and 19 in the elderly. So what's been happening? So the first serotypes that you need to know is that Prevnar, the 7-valent, is not available anymore. Synflorix has got those 7 serotypes, which are common to both, and they have 3 more serotypes, 1, 5, and 7F. And you don't have to remember them, because serotype 1, so I'm a clinician, I like looking at numbers of cases. Epidemiologists love incidence. So whatever graph you prefer is up to you. It generally shows the same thing, but it just gives you a better feel. So you can see how many elderly cases there are compared to childhood cases, but you can't really see that in the incidence. That's the main difference. But you can see that serotype 1 started going down before PCV13 came in and continued to go down. It was just doing its own thing, and it would have gone down anyways. And when the vaccine came in, whatever was left, serotype 1 virtually disappeared. Serotype 5 doesn't cause a lot of disease in the UK. There was a little bit of a blip after PCV7, but you saw that it's gone before PCV13 came in. So that was never a problem. 7F was a huge problem because it was responsible for more than 10% of meningitis cases in England and Wales. So this was a nasty serotype with bad outcomes. And what was really good is when Prevnar 13 came in, you can see very big reductions in cases, and 7F is no longer a problem. And this was one of the major successes of changing the vaccine. The three serotypes that are important, the two serotypes, 6A is not important, is 3 and 19A. Okay, if you want to hold an intellectual conversation with the pneumococcologist, ask them about serotype 3 and 19A, because everybody has an opinion about it. Okay, and no two will agree. Serotype 3 has always been trouble. So with the polysaccharide 23-valent, serotype 3's vaccine effectiveness is virtually zero. The serotype 3 has a very thick capsule, and it releases capsule blebs. And so you need a lot of antibody to kill it, and it is probably unrealistic for the vaccine to make that much antibody to kill serotype 3. So there were concerns that this serotype will never be benefiting from the vaccine, and GSK had serotype 3 in the vaccine, and they took it out because they didn't think it was going to work and could do more harm than good. And so Pfizer kept the vaccine, the serotype 3 in the vaccine, and we weren't sure what was happening. But you can see that it does a lot of bouncing. But when Prevnar 13 came in, you can see that cases started going down. So in our 2013-14 paper, we said, it doesn't matter, it's going down. This is fantastic. We're very happy with it. Serotype 3 is not a problem. And as soon as we published the paper, it started going up. And we have more serotype 3 cases now than we did even before the vaccine came in. If you measure vaccine effectiveness with a different study, it's got a slightly positive point estimate, but the confidence intervals are very wild. They cross zero. It's very hard to try and understand how serotype 3 can be protective if you're getting these massive increases in all age groups. And so serotype 3 is a bit of a downer because it remains one of the most important serotypes causing disease in the UK, and it's associated with a relatively high case fatality, unfortunately. 6A is not a problem because 6A started going down before the vaccine came in because there was some cross-protection with PCV7, which has 6B, and then it went down really nicely after Prevnar 13. So 6A is not the problem. 19A is the other one. Now, 19A is really important because it's not contained in Synflorix, but it is in Prevnar 13. And some of you may have gone to the pharmaceutical symposia, and you'll be told that actually countries that use Synflorix have big problems with 19A because it goes out of control because there isn't any indirect protection for 19A. So the UK has never asked for the 10-valent to enter into the program, and we've always stuck with the 13-valent because we're worried about 19A. And the reason is that if you get direct protection against this serotype, which was a major replacing serotype after Prevnar 13, then you don't want to take a vaccine that doesn't give you indirect protection, and that was the worry. So we've always stuck to 19A. And what you see is, for the first 4 years after Prevnar 13 came in, we're seeing huge reductions in 19A. Everything was working well. And then we published the paper, and look, it's all started going the wrong way. And we don't understand why 19A doesn't work, because it worked before. We had 4 good years of data, and then the last 3 years, it's not doing as well and might be going the other way. What is really interesting is if you do carriage studies in children, fully vaccinated children can carry serotypes 3 and 19A. So it's still in circulation, it's still being transmitted, and it's still causing disease. And these two serotypes, 3 and 19A, are the major causes of vaccine failure in children with pneumococcal disease. So it's still very, very rare. But if somebody says he's got vaccine-type disease, then your first one's going to be 3 and your second one's going to be 19A. You don't need the reference lab. All right, so the next big question is really, what was this increase in the non-vaccine serotypes that happened after 2013-14? And I can tell you that the main serotypes are serotype 8, 12F, and 9N. So you can see that you'll see a very, very emerging pattern in that the biggest increase, they all occurred after, so it went up a little bit after 2013-14, and then they accelerated. And it's always 65 plus, 45 plus, 15 plus. All the increases in the adults and older adults, and a little bit of an increase in children. So these three serotypes, 8, 12F, and 9N, are now responsible for 40% of all invasive disease in England and Wales, which I couldn't have told you 3 years ago. They have really taken over. They were always around, so it's not like they have suddenly appeared, but 3 years ago, they just decided to take off. All these serotypes are in the polysaccharide PPV vaccine, just so you know. The unusual thing about these serotypes is that they have a very high case carrier ratio. What I mean by that is that these are generally not carried. So they either come to a person, make them sick, or they move on to somebody else. They don't stay around and sit in carriage. Now, the concept of the conjugate vaccines was that when you remove the most virulent serotypes in carriage, you get decrease in vaccine type disease, but carriage rates in children remain at 50%, always. So they then start carrying other pneumococci. And our logic was that the serotypes that replace these nasty ones will be less virulent. So they stay in carriage, but they cause less disease, and that's why you get lower rates of pneumococcal disease. That was the logic. And that worked really well for the first 4 years, because we can see that the carriage rate remained at 50%. We could see that the vaccine serotype disappeared in carriage. We could see new serotypes coming in carriage, and they caused less disease. It was perfect until 2013-14, and then it changed. And what's really unusual is that these new serotypes are still not there in carriage. So we would have struggled to try and model this in any of our models, because the models assume carriage to be important. Does that make sense? Okay, so there are other important serotypes which are less important. 15A, we've seen big increases in the older adults, and that's stabilized. 22F and 33F both went up quite a lot after Prevnar 7, and these two serotypes are important because they are in the next 15-valent vaccine that is most likely to be licensed in the next few years. They are no longer the major causes of pneumococcal disease, but they were after Prevnar 7 came in. So the main serotypes causing disease vary by age group, but what you'll see is that 8, 12F, and 9N are the major ones, and serotype 3 still remains very high. And I want you to look at the numbers, because in 2016-17, there were 1,120 serotype 8 cases, but once you come down to 19A, you're talking 300 or less. Serotype 8 has really taken over. The good news is that serotype 8, these highly invasive serotypes are usually associated with respiratory infections like pneumonia, and they're less likely to kill you. So we have lower case fatality, we have more respiratory infections, but we have more cases. And then as you go down, you can see 19A is in the top 10, and then 7F is there, and then we have no vaccine serotypes. So the other vaccine serotypes have done really well. I sort of want to end this, my summary by telling you that even with the replacement disease and so on, we have prevented nearly 40,000 cases of invasive pneumococcal disease in the UK in the last 10 years since the vaccine has come in. So with everything going up and down, there is still a huge net benefit for the whole program. So to summarize, we are still seeing a 37% reduction in IPD compared to the pre-vaccine era, although this reduction is very minimal compared to the PCV13 era. The current PCV program continues to have a massive impact in children, and children are greatly protected directly and indirectly. The replacing serotypes were not expected. They're causing huge increases over the last 3 years that we don't understand, and it's almost all in the older adults. Currently, 3 serotypes are responsible for invasive disease in the UK, which is 8, 12F, and 9. And these all have high case carrier ratios, cause respiratory infections, are less likely to kill you. And we have prevented a lot of cases in the last 11 years. I want to finish off because What I can tell you is that there are currently no pneumococcal vaccines. It'll take another 3 to 5 years for the next pneumococcal conjugate vaccine to come through. We've got a bit of time before we can make any changes to our program. Okay, but there are a few things we can do that can make a difference. The one thing is we could help by improving the influenza uptake, because we know that influenza vaccine will prevent influenza infections, and the most of the deaths due to influenza are due to secondary bacterial infections. So by improving the influenza vaccine uptake, not influenza uptake, which is clearly a bad thing, it would make things worse. But also the polysaccharide vaccine. Now, if you have an opinion, I bet you it's going to be very strongly for or against PPV. It's Marmite, because either you think it's good or it doesn't work. Those who think it doesn't work will never use it. Those who think it may work don't have a problem with it. The reason for that is that there is little evidence that there is some short-term benefit. In the UK, when we do all our analysis, we can see that there is a 50% vaccine effectiveness in those who get it for about 2 years, and then it wanes rapidly. It's not zero, there is some benefit, and it's short-term, but it's better than zero. And since this vaccine is very cheap, it becomes very cost-effective to continue to give that vaccine. Now, if there was a better vaccine, if there's a conjugate 23-valent, we'd never use this vaccine. But while we have this vaccine, any benefit could be considered better than no benefits. Those who don't like the vaccine are worried about hyper-responsiveness, the fact that if you keep giving polysaccharide vaccine, you can remove your B cells, and that may increase your risk of pneumococcal disease. But in the industrialized countries where this is used, this has not really been seen. There are some studies that support that. This is a UK study where we found a 48% short-term vaccine effectiveness for 2 years. There was a study recently published in Lancet Infectious Diseases where there was a 30% effectiveness against pneumococcal pneumonia. And then there's a randomized control trial which basically said that they had 12 trials with 2,000 participants, and they concluded that there was a lower likelihood of community-acquired pneumonia, and the number needed to treat was 21, which is actually brilliant. And the authors concluded that there is some protection against community-acquired pneumonia and COPD exacerbation. So there is some evidence to suggest that we could continue using polysaccharide vaccines until we get a better vaccine. But clearly, we need a better vaccine. So I want to end by telling you that this is not my work. There's a whole team behind me that does a lot of the hard work, and I thank you for your attention.